All right, this is my little review of what you're expecting for our Forces in 2 Dimensions unit test coming on Friday, right? First piece from Chapter 5, because this is all encompassed in Chapter 5, was we talked about the Pythagorean theorem and we talked about the law of cosines. And the point here was we were taking two vectors and we were adding them together. And if the angles were at 90 degrees, we'd use Pythagoreans. If the angles were not at 90 degrees, then we'd use the law of cosines. I am not expecting you to memorize the law of cosine formula, but I do expect you to be able to use it, right? And we use that on any triangle that is not at 90 degrees. Some asked, what about the law of sines? Do you have to worry about that? No. You don't have to worry about the law of sines for this test. How do I choose which is theta? It's going to be... that's up to you, to be honest with you. They'll probably give you one of them. Yeah, they'll probably give you. Usually you go from where you started at. The origin, right? So I put these two vectors together. And then here's my resultant, my r. Where I started is my theta. It's a good question. Y'all with me? I don't believe you, but okay. Let's move on. Next, we talked about components, right? Where if I have a single vector, I can break that vector into its pieces, right? Into both its x and its y. Now, your textbook gives you formulas for x and y. I don't encourage you to memorize formulas. You need to know SOHCAHTOA, right? Some old hippie came a-hopping through our alley. That's how I know it. Some old hippie came a-hopping through our alley. That's old school. Old school. Okay? So, because y is opposite of theta, y is going to be sine. Because x is adjacent to theta, it's going to be cosine. But please understand, not every time is x cosine or y sine. It depends on how you draw your triangle. All right? So you be comfortable with adjacent and opposite. That's how you know which x or y to pick. Cool? The next thing we did was vector addition, which is basically you do this for a bunch of different vectors, right? This was our challenge problem with 10 different vectors, right? You do that 10 times. Get x and y, get x and y. Remember that you have to use this is positive, this is positive, this is negative, right? I got to use my coordinate plane, my coordinate system. So I take all those x's and y's and I add them together. Then I make a new triangle, right? Out of those two x's, the one x and the one y, I make a new triangle, right? So if I have an x, an rx that's equal to 50, and an ry that's equal to minus 75, I would go over 50, that's positive. I'd go down 75, that's negative, right? And then this would be my r. And this would be my theta. This would be rx, this would be ry. Does it make sense? And I simply then use Pythagoreans to find r, and I use the inverse tangent to find theta. And all that gives me the resultant, which remember has magnitude and direction. It has 110 newtons at 26 degrees east of north. Right? Or again, remember, you also can start here at 0 and go all the way around to 360. You can do either of those ways to talk about the direction. You cool? These 6 steps, right? The next piece we learned was about equilibrants. So an equilibrant is exactly the same magnitude as a resultant, right? If I got 110 on the other guy, 110 is my equilibrant. But it's in the exact opposite direction, right? So here's the example that we did from the challenge problem. 116 newtons at 67.6 degrees south of east. That was our resultant. We took all 10 of those forces. This is what came out. If you put them all into one, this is what it came out to be. The equilibrant then is the same amount, 116, same angle, 67.6, but it's now north of west. Are you with me? All right. So equilibrant, same amount, opposite direction. It's the one force that cancels the resultant. That's what an equilibrant is. That one single force. And then last but not least, we have the inclined planes pieces. Right? Where we tipped this upward, which made gravity now have both a force pushing into the surface and a force pushing down the surface. The one pushing in is the y component of gravity, which is the same as the normal force. The force pushing down the surface, they actually label this as Fm, the force moving the object. That would be our x, right? The x component of gravity.
Would it be the same, that Fm be exactly the same as the
As this line right here.
Yeah.
Yep, absolutely. And here's the y, which would be the same as that one. Yep, absolutely. Don't forget you've got your friction force up here, right?
And is that going to be the same but opposite of those two?
So it will always be in the opposite direction. It'll also be always be going up the slope, okay? Opposite of the way this guy is trying to move down the slope. Again, I'm not giving you any directions on how to calculate that. I just want you to make sure you know about it. We'll talk more about that as we move forward. Any questions that you have for me? It goes much faster when I don't have to write all this down when I already wrote it. And we just go through it. You're good? Okay. That will be the plan. I'm reminding you that you will have 30 minutes on Friday for this test. It's a half day, right? So classes are shorter. So there's 4 questions. That's it. 4 questions. Using these pieces. It's not like 4 A, B, C, D, E, F, G. No. It's just 4 questions. Okay? But again, you have those 30 minutes. So I want to make sure you're comfortable enough with the material that you don't take 25 answering one question. Does that make sense?